Okay, so hello everybody. I'm with Andre from for the Helm Europe conference, and he's playing a game I've wrote in 2 hours in Helm. So it's a snake, and it's awesome. So and today we are gonna uh, put some WebGL into it, and we are gonna do some new things uh, in uh, in Helm. So let's start. Oh, you lose. Okay, so let's start by showing the code. Okay, so that's the version I did. So can you go into the main.helm file? So yeah, that's the main file, and here we can see that we have some initialization of the snake and the apple, and then we have some subscriptions here to the keyboard, and we have also a subscription for the control of the keyboard and uh, for the game itself. So can you go down a little bit? Um, so here is the whole game. We have like, can you go on the update function? Okay, so the update function is really like the interesting part is in the tick time message. So here the tick time is moving the snake, so it returns a new model. And in the move snake function, can you go to the move snake function? We have we unstructure the model with direction, snake, and apple, and we let the moved snake, and we add a new vertebra to the snake, a new chunk to the snake, in the direction decided by the user. Then we look if we have a collision between the moved snake and the apple. And the final snake is if the apple is eaten, then we return the moved snake. And if the apple is not eaten, then we remove the last vertebra. So you can look at the code for details, but it's a pretty simple snake. And then if he is in collision with himself or a wall, then we re-init the game. So we return the init function, the call of the init function, and else the new snake equals the final snake. And if the apple is eaten, we generate a new apple in the commands. Can you just go to the collision function? So that is a collision with himself or wall. It takes a snake, and we destructure the snake in head, colon, tail, and we like it's true, the collision is true if we have a list.member of head and tail, which is a standard function, and or if the snake is out of the space of the game. And list.member, it works because head is simply a couple of two coordinates, and tail is a list of couples of two coordinates, and it just works. It's really easy. And then you can go to the collision, just up. Collision is between an apple and a snake. It's the same. It's just a list.member of apple inside the snake, which is a list of vertebrae. So basically, it's almost it. We can look quickly at the view. The view is in the file views. So here we have walls view, the sprite view, and it's like we have a div with a world view and the score view. The score view is just the number of excuse me. So the score view is it's the length of the snake, and the world view is the walls view, the apple view, and the snake view. And the snake view, it's just snake list.map vertebra view of snake. And if you go up, you can see that the sprite view, which is called by apple view and vertebra view, is just using the position absolute on top and left, and text val. And that's it. It's not very complicated, and it works pretty simply. And Andre did something really amazing. He did a pull request, and what he did in that pull request is that he added WebGL to it. And the crazy thing about it is that when you look at the code, nothing in the game logic changed. Only if you look at the diff, you will see that apart from the window handling, nothing changed, and that's really crazy. Okay. Okay. Yeah. Okay. Yeah. What could be really nice is to have, like, I don't know if it's doable, but yeah, toggle would be awesome. But we could also have the two games, one after the other. The two views. But yeah, that's not very complicated. But yeah, we can imagine lots of things. Message. Okay. 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 Um, yeah. Uh, I think most people have questions about what's the like why do we need a vertex shader and a fragment shader? Okay. But there we only have like 100 and how many lines do we have to do the whole WebGL code? It's 150 lines. Uh, so that's really great because like I used to believe that WebGL code was really big, but there it looks quite nice. Uh, can you show us the result? Oh, nice. Okay, nice. Okay, so um, uh, I believe we can stop the video here and do another one with the new with what we want to do next. Okay, so thank you everybody to listen to this video, and we will come back in a minute.